Hello everyone and welcome back to On the Spot STEM. Today we'll be doing problem number 25 from the 2018 AMC 12B. This problem reads, circles omega 1, omega 2, and omega 3 each have radius 4 and are placed in the plane such that each circle is externally tangent to the other two. Points P1, P2, and P3 lie in omega 1, omega 2, and omega 3 respectively, such that P1, P2 equals P2, P3 equals P3, P1, and line pi plus 1 is tangent to omega I for each I equals 1, 2, 3, where P4 equals P1. See the figure below. The area of triangle P1, P2, P3 can be written in the form square root of a plus square root of b for positive integers a plus b. What is a plus b? So we look at this diagram and we see the setup is quite complicated, but one thing that is the general heuristic on problems like these is to always draw the center of the circle and connect it to the points that are nearest to it. So we'll connect this center to P3 and P2, and then we'll connect the center of this circle, omega 2, to P1 and P2, and then we'll connect the center of omega 1 to P3 and P1. Okay. And what we see is that these lengths, the opposite lengths of this hexagon that is formed, are very similar. They're actually the same. So these three lengths are the same, and these three lengths are the same. And if you connect the diagonals, the other diagonals of this hexagon, since P3, P1, and P2 are already connected, you'll get another sort of equilateral triangle. So, well, what can we do with this configuration? Well, do we know anything about this? We know that the angle over here is 30 degrees. And this is because this is a 90-degree angle because it's a tangent, and this is an equilateral triangle. So this angle over here has to be 30 degrees. And thus, we can try to use law of cosines or law of sines to find out the side length of this triangle. We have that this radius is 4. Let's call this side length S. And we don't know the length of this value over here yet, the distance from the center to pi, so let's call that x. Then by the law of cosines, we have that, or by the law of sines, if we call this angle theta, then we have that 4 over sine theta is equal to x over sine 30. Sine 30 is equal to 1/2, so this simplifies to x equals 2 over sine theta. So now that we focused on the triangle selecting the center P1, P3, let's focus on the triangle such that its obtuse angle is on pi. So if we look at this triangle over here, this has side lengths of x, 4, and another side length q. We'll try to relate q to s and see what can come out of it. Or we'll try to find the length of q explicitly. Well, if you look at the diagram carefully, you know that these circles are all tangent. So that means the length of q is equal to 8. Because since they're tangent, the line connecting the centers has the distance is basically just equal to the sum of the two radii, the distance. So it's equal to 4 plus 4, which is 8. So now we can use law of cosines on this triangle, because we know that this angle is theta and this angle is 90. So we have that 4 squared plus x squared minus 4 times x times 2 times sine of theta plus 90, or cosine of theta times 90 plus 90 is equal to 8 squared, which is 64. And cosine of theta plus 90 is equal to negative sine theta. So this simplifies to x squared plus 8x sine theta is equal to 48, because 64 minus 16. Now we can substitute x equals 2 over sine theta over here, and this term collapses to 16. So we have x squared plus 16 is equal to 48, and x is equal to 4 root 2 upon simplification. And we also have that x is equal to 2 over sine theta, so sine theta is equal to 1 over 2 root 2. So now let's go back to our diagram over here. So we can fill out the value of x from this. So it's equal to 4 root 2. And now we can use law of cosines on this triangle over here to find the value of s. Because by law of cosines, we have that 4 squared plus s squared minus 2 times 4 times s times cosine 30 is equal to 4 root 2 squared, which is 32. And so this becomes s squared minus 8s cosine 30, which is 4 root 3s, is equal to 16. So s minus 2 root 3 whole squared is equal to 16 plus 12 after completing the square. And s is equal to 2 root 3 plus 2 root 7 after simplification. So now that we have the value of s, all we have to do is find the area of this in the form that it's requested. So the area is equal to root 3 s squared over 4 is equal to 2 times root 3 plus root 7 whole squared times root 3 over 4. The 2 over here will simplify with the 4, so we have the area is equal to root 3 plus root 7 squared times square root of 3, which is equal to 10 plus 2 root 21 times root 3, which is equal to 10 root 3 plus 2 root 63. And this is equal to square root of 300 plus the square root of 252. And that's equal to the area. Looking at our requested form, it's equal to root a plus root b. So a is equal to 300 and b is equal to 252. So 300 plus 252 is equal to 552. That is answer choice D, and we are done. Thank you for watching. If you enjoyed this video, please like and subscribe to our channel, and tell your friends, family about this channel. The AMCs are coming up soon, so make sure to look for more problems on our channel up past AMCs. Thank you.